1 video for 4-1, inverse variation in the reciprocal function. So this first video is going to focus on the inverse variation aspect of this lesson. There is a model and discuss in your textbook and in your student companion. You may or may not have to do that depending on other directions from class. I'm going to skip over that for right now. So we have our essential question: how are inverse variations related to the reciprocal function? So an inverse variation is some relation between two variables such that as one variable increases, the other one is going to decrease proportionally. So simplified, your product, x times y, has to be some type of constant term. So you have an inverse variation if you multiply your x and your y together, and for every ordered pair, you get the same product. So if we look down here at part A, if I multiply my x's and y's together, 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is also 12, 4 times 3, 6 times 2, 12 times 1. Those all give me 12. So yes, this does represent an inverse variation. If we look over at part B, if I start multiplying my x's and y's together, I get 20, I get 34. I actually don't have to go any further there because I already found something that does not work out. Even if there is something else here that would multiply to 20 or multiply to 34, they are not all the same constant value. So this one is not an inverse variation. So not an inverse variation. So here's your concept for inverse variation. When you do have that relation between x and y, we can say x varies inversely as y. So there are 3 different equations you can use to model this. Those are highlighted in blue. You can have y equals k over x, where k is your constant of variation. X equals k over y, or you could do the xy equals k. All 3 of those are acceptable for an equation to model an inverse variation. Typically, you will have a value for k. So for example, in part A of the first example that we did, my k would be 12, because k is whatever constant term you get whenever you multiply your x's and y's together. That's why it's called the constant of variation. So here's example 2. In an inverse variation, x is equal to 10 when y is equal to 3. It says inverse variation, so it has to have some k that is my constant value for my product. It says write an equation to represent the inverse variation, and then find the value of y when x is equal to 6. So there's 2 things we have to do here. We have to write an equation, and then we have to find the value of y when x is negative 6. So I'm going to use the xy equals k equation first to find my k value. So that's 10 times 3. So 30 is my k. So now we have a couple different choices for how we can write the equation. You could say xy is equal to 30. That would be acceptable. You could do y is equal to 30 over x, or you could do x is equal to 30 over y. You don't have to do all 3 of these. You only have to do one. Just make sure that you pick one and you stick with it. Then the second part, find the value of y when x is equal to negative 6. So we have negative 6 times y is equal to 30. I would divide to solve for the y value. Y is negative 5. You would have to have both things in order to get credit for this question: the equation and then the value of y. Here's a real-world question dealing with inverse variation. It says on a guitar, the string length S varies inversely with the frequency F of its vibrations. So that means SF has to equal some K. The frequency of a 26-inch E string is 329.63 cycles per second. What is the frequency when the string length is 13 inches? So I have to find my K. Notice this one doesn't actually ask for an equation, but I am going to come up with one to allow me to answer the question of what the frequency is. So frequency is going to be an F, so I'm trying to solve for an F here. It tells me for this first part, the frequency of a 26-inch, so 26 inch is going to be my string length. The frequency is 329.63, which means my K value, and I do have this question already worked out. You would probably need a calculator to go through and actually figure out this number. But that number is going to be 8,570.38. So that's going to be my K. So my equation is going to be SF is equal to 8570.38. So now it says, what is the frequency when the string length is 13 inches? So 13 is going to be my S term. And I'm going to divide to solve. So I'm going to divide both sides by 13. And for my F, I get 659.26. And my label is going to be cycles per second. And you can see here, this does actually make sense because this does vary inversely. So if you're going from 26 to 13, you're actually dividing that by 2. So it makes sense that the frequency is multiplied by 2 because you're going to be going the other way. If you divide one term, you would actually multiply the other term. That's where the varies inversely comes from. And 659.26 is about 2 times the 329.63. That's going to wrap us up for this first video on inverse variation. The second video is going to focus on the reciprocal function, which is a way to graph the inverse variations. So please go back through and rewatch this and reach out to me if you have any questions at all.